Hello students, welcome you all to the video lecture on Control Systems Engineering. Today we are going to see the time response of first order system with unit step input. Okay, so this is the first order system, right? So where you have the forward path gain as 1 by st, reverse path gain as 1. So first what we have to determine is we have to find out the closed loop transfer function for this first order system. Okay, so the closed loop transfer function for the first order system is given by T of s is equal to output by input C of s by R of s. So in this system, this is your output, this is the input. So both are in S domain. Okay, so the transfer function is also in S domain, C of s by R of s. It is generally given by G of s by 1 plus G of s H of s, where G of s is nothing but forward path gain, H of s is nothing but reverse path gain. That is, here this is the forward path gain, this is nothing but G of s. Reverse path gain, this value is nothing but H of s. Okay. So in another way I can say that this system is unity feedback system. Why? Because in the reverse path gain the value is 1. Okay. So once you know all these things, you can substitute the values in closed loop transfer function, that is C of s is given by T of s is given by C of s by R of s, which is nothing but G of s value is 1 by st divided by 1 plus, again G of s value is 1 by st, H of s value is 1. So let me solve this equation. Numerator you can keep as it is. Denominator, when you see the denominator term, the common LCM is st. So multiply this term with st. So 1 into st will become st. So this term is already having the denominator as st, so no need to multiply anything, just write as it is. Okay. So once you have written like this, we know that this term get cancelled. So final transfer function is nothing but C of s by R of s, which is given by 1 by, I can write this term as st plus 1. Okay. So this is your T of s. And again coming to the question. So what we are going to find out? We are going to find out the time response. Okay, that is, response is nothing but output. Output in T domain only we are going to find out. That is nothing but time response, right? That is, I am going to find out the output which is in T domain. That is C of T I am going to determine. So I have to determine what is C of T. Okay, so I have to rewrite the equation such that I have to find out first what is C of s, and then from the C of s I can apply inverse Laplace transformation, I can find out what is C of t. Okay. So again from the question, time response of first order system with unit step input. The input is nothing but unit step input. So what they are telling, this input is nothing but unit step input. Unit step input is nothing but 1. Okay. So your R of t is nothing but 1. Okay. So R of t is given, which is nothing but unit step input. From R of t I can find out what it is R of s. Okay. So using those values I can easily determine what is C of s first, and then I can find out what is C of t, which is nothing but your time response. So again C of s by R of s, what we have determined, it is 1 by 1 plus, sorry, st plus 1. Okay, either st plus 1 or 1 plus st, whatever it may be. Okay. So given, again given is unit step input. Unit step input meaning that your R of t is 1. So whenever R of t is 1, I can apply Laplace transformation for this term. So Laplace of 1 is nothing but 1 by s. So I can determine that R of s is 1 by s. So once you have determined that, you can cross multiply this term. So it is R of s into 1 by st plus 1. So substitute your R of s value. R of s is 1 by s. So 1 by st plus 1. So which is nothing but 1 by, there is no common denominator, so multiply both the term, right. So your C of s is now 1 by s into st plus 1. So again I need to find out C of t. but I cannot determine C of t directly. I don't have any inverse Laplace transformation for this term directly. So I have to apply the partial fraction. Okay. So C of s is equal to, again while applying the partial fraction, I require s plus the term. I don't want st and all. Okay, s plus the term I require. So let me take t outside. Okay, before applying the partial fraction, let me simplify this term. Let me take t outside. So 1 by st into s plus. So when you take t outside, this term will become s, this term will become 1 by t. That is divide by t in both the term. Okay, t can get cancelled, here it is 1 by t. So now again, let me take all your constant in the numerator. So 1 by t, let me keep in the numerator. This becomes s plus s into s plus 1 by t. Okay, this is your final C of s. So for that only I have to apply the partial fraction. So a by s plus b by s plus 1 by t. So take your numerator in the left hand side 1 by t, which is equal to a into, okay, compare this term and this term, already s is there. So just multiply s plus 1 by t. Again compare this term and this term, already s plus 1 by t is there, which is not there, that you have to multiply with b. So let me substitute some values, right, so that either a or b get cancelled, another term I can find out. So simply, since it is s, you can substitute s equal to 0 and another term s plus 1 by t, so I can substitute s equal to minus 1 by t, so that this term get cancelled. So when s equal to 0, left hand side I don't have any s term, so just substitute 1 by t as it is. Here s equal to 0, so a into 1 by t. So anyway, this term get cancelled, just a is equal to 1. Right hand side, again for finding out your b, let me substitute minus 1 by t. Again left hand side I have 1 by t, you keep as it is. When s equal to minus 1 by t, this term get cancelled, so I have b into minus 1 by t. Anyway, this term get cancelled, b equal to minus 1. So once you have determined a value, b value, let me substitute in this equation, right, in this C of s. Okay, C of s is a by s plus b by s plus 1 by t. So substitute these two values here. So C of s is equal to, a value is 1 by s, b value is minus 1. So minus 1 by s plus 1 by t. Okay, so now we can easily determine C of t by applying inverse Laplace transformation. So C of t, when I apply inverse Laplace, C of s will become C of t, and inverse Laplace of 1 by s is 1. Inverse Laplace of 1 by s plus a is nothing but e power minus a t. So using that, it is 1 by s plus 1 by capital T. So it is e power minus t by capital T, right. So C of t is nothing but, for this term it is inverse Laplace is 1, and for this term e power minus t by capital T. Okay, this is your C of t. So once you have determined C of t, okay, let me draw the response also. Okay, response, this is your time response, right. So you have determined the final time response which is required in the question, right. This is your time response. Let me draw the graph for the time response also, and we can finish the derivation. Okay, so simply again, what is r of t input? R of t is 1 for t greater than or equal to 0. So I can draw the input signal as just a horizontal line with the amplitude 1. This is your r of t. For t greater than or equal to 0 means 0 to infinity, right. 0 to infinity, the amplitude is 1. This is your input, right. Okay, now I have to draw the output time response. So I have to find out what are all the values for your C of t. Okay, here it is amplitude is 1, so just you have drawn the simple line. Now I have to determine how the curve will be here. Okay, so let me take this equation as it is, 1 minus e power minus t by t. Okay, so from 0 to infinity, some few values let me take and substitute and find out your C of t value. So let me take t equal to 0. So when t equal to 0, what is C of 0? 1 minus e power, 0 by t. Anyway, e power 0 is 1. So 1 minus 1, which is nothing but 0. Okay. So c of 0 is 0. This is my first value. Similarly, let me substitute some other time t value. Let me take it as 1t. Okay, some time constant I am taking 1t. So c of 1t is, wherever I have small t, just substitute 1t. So 1 minus e power, here small t is 1t divided by this capital T. Okay, so t get cancelled. So 1 minus e power minus 1 I have. Okay, so I have to find out, okay, using your calculator, e power of minus 1 is nothing but this value. 1 minus, this answer is 0.63. Okay, so this value is 0.63. Similarly, let me substitute some other value also. Let me take t is equal to 2t. So c of 2t is 1 minus e power minus 2t by t. T get cancelled. So 1 minus e power minus 2. So e power of minus 2. Okay. So 1 minus the answer is nothing but 0.86. Okay. So it is nothing but 0.86. So let me take final value. Let me take final value as infinity. So c of infinity is 1 minus e power minus infinity by t is nothing but minus infinity. So anyway, e power minus infinity is 0. So 1 minus 0 is 1. Okay. So these are all the values you have obtained. Okay. So using these values I have to draw the curve. Okay. So let me draw here itself so that you can easily understand the output. Let me take x axis as t, y axis is c of t. Okay. So at 0 the amplitude is 0. At 0 the amplitude is 0. At 1t, somewhere I am taking 1t, somewhere I take 2t, and finally infinity. Okay, substitution values. So at 1t the amplitude is what? 0.63. Okay, so let me take 0.2, 0.4, 0.6, 0.8. Final value is 1. Okay, so 1t the value is 0.63. So somewhere around here 0.63 will come here. 2t the value is 0.86. Okay, so somewhere here it will come. Okay, roughly you can draw. At infinity the value is what? 1. Okay, so just connect all the dotted points. Okay, from here, so you have one point here, next point here, next point here, next point here, right? So this is your time response. Okay, so when you give input like this, output you will get like this. Okay, time response of first order system. And again, why it is called first order system means, what is actually your C of S? What is actually your T of S? T of S is 1 by St plus 1. Okay. So when you see this term, right, 1 by St plus 1, denominator, how many S terms are there means that gives your order. Okay. So only one S is there. Suppose if you have S square term, or S into S like that, or St plus 1 into St plus 2 like that, okay, then I can say that two S terms are there, then it is second order system. Okay, so only one S term in the denominator, hence it is called as your first order system. Okay, so this is your final time response of first order system. Okay, thank you, thanks for watching.